All right, welcome. Today is Friday, December 9th, and I am not here today, so I've made a new podcast to help you guys with your assignment. If you look, today we are doing a molar mass worksheet number 2 and video entry number 3. So pause this video, find your notebook that you are taking notes in for videos. This will be a short notes, probably 1 or 2 minutes is all, and you can get started on your homework assignment. This will be video entry 3, percent composition. All right, so on your notebook, today is Friday, December 9th. This is entry number 3, called percent composition. Probably didn't do that very legible, but you have a pattern that you've been using. Continue with that. All right, let's just quickly review the mole. Remember, the definition of molar mass is the mass of 1 mole. If you remember that 1 mole of marshmallows has 6.02 times 10 to the 23 marshmallows in it. If I went and got 6.02 times 10 to the 23 jelly beans, I would also have a mole of jelly beans. 2 different ways you can write this problem. In this case, even though we have the same number of pieces of marshmallows and the same number of pieces of jelly beans, they don't weigh the same. So our job is to molar mass it. And the definition is the mass of 1 mole. So, if you recall, we've done that before. We did that yesterday in making our box. So let's just review that real quickly. The molar mass. Let's go ahead and molar mass water. So if you recall, you're going to write the formula for water. You're going to write all the elements that are found in water. How many atoms of each. Get on your periodic table and look for the molar mass of each one. This one is one I've asked you to memorize. At that point, you are welcome to go ahead and multiply them together and add them up. 2 times 1 is 2. 1 times 16 is 16. Add that up for a total molar mass. Actually, if you recall, we want everything to the 10th. I made everything to the 100th, so erase that. Not a big deal at this point. And you have the molar mass of 18. That would be how you make your box. Here is a visual of what that might look like without rounding. So there's my water molecule. There's my oxygen. It has a molar mass of 16 in our case when rounding. There are 2 hydrogens, each one at 1, and therefore the molar mass is 18.0. So, definition of percent composition. Let's talk about percent composition. You guys have done percent composition before. The definition is take the part that you're looking for over the whole thing. In this case, we're talking about water. So the total molar mass of water molecule is 18. And in this case, we would have to find the percent composition of hydrogen and the percent composition of oxygen. There are 2, if you recall up here, 2 total grams of hydrogen out of 18 total grams times 100 for percent. And in oxygen, there are 16 grams of the 18 times 100. Remember, in dealing with percents, the number has to add up to 100. So, pause this video, get your calculator out, calculate all 3 of these numbers, and then check your work. All right, welcome back. I hope you have plugged that in. I need to get my calculator out to take 2 divided by 18 and keep it to the 10th, or 2 sig digs. Let's do 3 sig digs in this case. Would be 0.111. Oh, I forgot times by 100, so that would be 11.1%. 16 divided by 18 times 100 is 88.9. Sometimes with rounding, it does not add up to 100, but in this case, it does. And that is the percent. You can stop now and go to your homework. Those are your notes for this video on Friday, December 9th, called Percent Composition. All right, so your homework is to do a bunch of molar mass problems. You have the hour. I asked you yesterday, I believe, if not, to practice writing and balancing formulas. I'm going to go ahead and get out a piece of paper for this, even though it's the same one. So, first of all, if you are not coming up with the correct answers for just writing formulas, potassium's a +1, chloride's a -1, cross and drop, that is what I want you to come in and get some help on. Okay? I also want you to practice naming. This is an ionic compound. That ion name is sodium. That ion is carbonate, and that is all you have to do for that. Pause and catch up. And let's do one more. Calcium hydroxide. Calcium is a positive. Hydroxide is a polyatomic ion that has a -1. If you write the charges, you are more than welcome to cross and drop at that point. So that's the first thing you will be doing in regards to writing or naming formulas. Second of all, you will be molar massing. The depth question is, what is the mass of 1 mole of each of these compounds? So you would write the atoms out, how many there are, look up the potassium is a 39.1, chloride is a 35.5, times those together, add them up, 39.1 plus 35.5, 74.6. Don't forget to put your units. That is how much 1 mole would weigh. Now, the directions don't say this on this worksheet, but the final thing you're going to be doing is also add percent of oxygen. So that gives you a little bit of percent composition practice, but not too much. So, for example, in potassium chloride, how much oxygen is there? That's an easy one. There's 0% oxygen. In this case, let's do one more. You would have to make your box for sodium carbonate. I have 2 sodiums, 1 carbon, and 3 oxygens. Oxygen I've memorized. Carbon we look up. And sodium is a 22.98, so that rounds to 23.0. I'm trying to purposely go a little bit fast right now because I want you to actually get to the point where you have to pause, try it yourself, and then watch the video. So now I'm adding them up, and I have a total mass of 106.0 grams per mole. That's the second part of this assignment. And remember, the third part is to add percent oxygen. So here's the question. Of a sodium carbonate ion or compound, how much is oxygen? It looks like I have 3 oxygens in 3 atoms of oxygen in a sodium carbonate ion. But that is not just, that's if they're all equal. So what we need to come over here and do is find out the mass of the oxygen over the mass of the whole compound. And then we are able to figure out the percent. So hopefully you will come across a lot that are 0% oxygen. That will help speed up your homework. Hopefully you will find some time to stop and pause this video. And that's it. Work the whole hour if you would, and email me or My Big Campus message me if you have any questions.